Hello, everybody. Today we have another quiz session on aldehydes, ketones, and carboxylic acids. And the participants who could answer the question on my website were these. Please introduce yourself.
Hello, my name is Amaan and I study in DPS.
Hi everyone, this is Ashita Saxena studying in DPS.
Hello everyone, I'm Khushi Shetty. I'm from DPS Nehru as well.
Hello everyone, this is Prisha from DPS Nehru.
Okay, so all are set and excited. So let us start. Analyze the name of this given compound. This is a CHO. This is a CH2. You have a CH2. You have a CH with a CH2, CHO, CH2, CHO. Anyone wants to try, or should I take the marks? Okay, Ashita.
3-ethanol hex 1,2 dial.
Anyone wants to try? The question passes. If you get 50% right, also I'll give you 1 mark.
2-acetaldehyde 1,6 hexa diacid. Yeah.
Yes, Prisha?
2-acetaldehyde 1,4 butane 1,4 dial.
I think the closest answer was given by Amaan. I would like to give him the marks, but yes, Amaan, you shouldn't have fumbled. So it's a hexane 1,6-dial. Right? Everyone agrees that this is a hexane 1,6-dial. And on the third carbon, we have a formyl and a methyl. So we call it 3-formyl methyl. 3-formyl methyl hexane 1,6-dial. I would like to give this 0.5 marks to Amaan for being, he said acetaldehyde. That was very creative of him. Yes, it is acetaldehyde kind of, but we call it a formyl methyl. Amaan, what happened to the hexane 1,6-dial? Why did you fumble in that? It's okay. 0.5 mark goes to Amaan. Pentan 2-one and pentan 3-one show what kind of isomerism? Yes, Amaan.
Positional.
Yes, Ashita.
Ma'am, I would like to go for the same answer. Positional.
With a different answer? Yes, I would give this mark to Amaan once again. It is position isomerism. 2-one and 3-one are position isomers, but we have a better word for them. Another isomer for them, and that metamerism. Metamerism. It's just like ethers. They show metamerism. Yes, Amaan has 1.5 marks. There's another fill in the blank. You have propanal and propanone. Propanal and propanone. You figured out the compounds which will have a higher dipole moment. Yes, Amaan?
Propanal.
The question passes. So obviously the lucky one. Yes, Ashita, the lucky one.
Propanone.
But I would like the reason.
Propanone.
I would like the reason because 0.5 marks is yours. But the reason, if it is correct, I would give the other 0.5 mark to you.
The ketone has a higher dipole-dipole interaction. It has more dipole-dipole interaction than the aldehyde.
No, you're again beating about the bush. I said why. Of course, you're lucky, but the reason is
ma'am.
Yeah.
Both the methyl groups get attached in the ketone, whereas in aldehyde it's only one methyl group
Yeah, I will
and
give
one
you the
H.
full 1 mark. I would give you the full 1 mark. The CH3 groups are electron releasing groups. The CH3 groups are electron releasing groups. So hence they make the ketone have a higher dipole moment. And it is there in the NCERT clear cut that acetone has higher boiling point compared to propanal. Yes or no? It's because of the higher dipole moment, electron releasing groups. Higher dipole moment leads to a higher boiling point for acetone, which is approximately, I think, 329 Kelvin and 322 Kelvin. Right? Okay. Please keep your pen and papers ready because we have a writing question. So the question is, what happens when allyl alcohol is treated with Jones reagent? Yes, Ashita, can I see whatever you have scribbled? Okay, Jones reagent is correct, but it is not allyl alcohol. Ashita. Okay, I'll give you a hint. Allyl alcohol is anyone with the structure of allyl alcohol? Very good. Why don't you write the product, Prisha? If you write the correct product, I'll give you 0.5 mark. Snatch that point from Prisha. Come on, guys. Then it's time up. It's time up for the question. Just the alcoholic group will change to aldehyde group, keeping the double bond intact. It's an oxidation. It's a partial oxidation where the alcohol will change to aldehyde. That's all. Prisha, why don't you complete the reaction? At least partially you were correct. So you'll get enal, isn't it? Prop 2 en 1 al. Enal. Just show me quickly, Prisha, quickly, for the 0.5 marks. So Khushi, yeah, yet to open your account. Come on. Yes. Aldehyde. Joe is missing. It's okay. Doesn't matter. So 0.5 marks for Prisha. Now it's a very easy question. So keep your hands on the button. Okay. You have, once again, a question which you have to write and show me. Okay. You have dicyclohexyl ketone. Dicyclohexyl ketone, when it is reduced with sodium borohydride, followed by acidic hydrolysis, what would you get? Yes, Khushi. Can I see whatever you scribbled? Oh, that's excellent. That's excellent. Very good. Khushi has opened her account with 1 mark. You have the dicyclohexyl ketone with NaBH4. It will undergo reduction. You will get the alcohol. That is plain and simple. Very good, Khushi, on opening your account. We will go to assertion reason. I mean, the monotony has been broken, and it's so nice that each of you have scored a mark. And Amaan is the, he's still on the winning post. So come on, guys, give him a challenge. So this is the assertion reason which you have for yourself. The pKa of acetic acid is lower than that of phenol, and phenoxide is more resonance stabilized than acetate ion. Yes, Amaan?
BB.
Bombay. Yes, Ashita?
C, assertion is true, but reason is false.
I think you would have to justify that.
The phenoxide ion, when it undergoes the resonance, when it undergoes resonance structures, it contains only one structure. So it is not fully resonance stabilized than acetate ion. Acetate has more resonance structures as compared to the phenoxide ion.
Oh, but phenoxide, we can go on revolving the negative charge around the pi cloud, and we have a lot of structures for phenoxide ions. The correct answer is when we are doing the resonance for phenoxide ion, the negative charge actually goes to a carbon, which is not so electronegative as the acetate ion. In acetate ion, you have the resonance where both the negative charges are on the oxygens. The oxygens are electronegative. So it would love to take the negative charge. Whereas the phenoxide ion, when you're doing the resonance, the negative charge dislodges on the carbons. The carbons are not so negatively charged. That is why the phenoxide ion is not so resonance stabilized as the acetate ion. So Ashita, never mind, you got it correct. We'll go to the second assertion reason. Yes, now for the hands up. Yes, Khushi?
Is it B?
Did you say
B
Bombay?
for Bombay. Yes.
I would like a justification. Yes, 0.5, correct. Yeah.
So benzoic acid and phenol can be distinguished by NaHCO3 because benzoic acid, carboxylic acids, they release a brisk effervescence when they are reacted with NaHCO3.
Yes.
But the reason, benzoic acid is a stronger acid, but that is not the reason for the assertion.
Yes, perfectly said. So now I have another, I would call it a very peculiar question. Okay, I have Again, it's a writing question. You have but2n1-al. I would want you to write down the structure. but2n1-al. And you're given sodium borohydride followed by hydrolysis. You're given sodium borohydride with hydrolysis. I would like you to give me the major and the minor product. Yes, Prisha? Okay, you have given me one product. I want the second product. Prisha, I think you have written but2n1-all, isn't it? Yes, yes. So 50% right, 0.5 marks. And that is the major product, correct? Anyone for the minor? So another 0.5 is reserved for anyone who wants to try. Time up, time up, time up. So it is butanol. You know, but2n1-all is 60%, and butanol is the minor product, which is 40%. NaBH4 can selectively reduce the double bond also, along with the aldehyde. Okay, so that is the minor product to keep in mind. So next question. I think you'll have to listen to the question and draw the structure. Right? Draw the structure. What happens when acetone undergoes trimerization reaction in the presence of concentrated sulfuric acid? Anyone wants to try, or should I take the marks? Time is running out. You would have to completely dehydrate it. When you take out the water molecule, you'll get mesitylene. Anyone with the structure of mesitylene, I'll give you 0.5 marks. Yes, Ashita?
This is the structure for mesitylene.
Yes, you can show me. Yes, I'll give you 0.5 marks. This is mesitylene. So we have a total of how many carbons? 3, 6, 9. You can count it. 6 for the benzene and 3 more for, it's completely dehydrated. Concentrated sulfuric acid is a dehydrating agent. Yes, Ashita, 0.5. My God, this game is going tough. In this reaction, you've got to find out why. Work it out. Work it out. Yes, Ashita has already raised her hand, so I have to give her a... Yes, you tell me which option. Ashita.
B option.
Oh, yeah, the B option.
Oh my God, both are correct. Yes, correct. So, Amaan, can you show me the answer also?
We
Write
can't
it.
even. Not written it.
So I'll give the marks to Ashita. I will give the marks to Ashita. Okay, so both of you have said B, but Ashita was quick in writing it down. So yes, Ashita gets 1 mark. We go to the next question. We have a winner now. We have Ashita with 2.5. Come on, guys, don't let her win. Yes.
It is ammonical AgNO3, which is also the Tollens test. So we can distinguish it by that.
How is it? How is it?
How? Like you want the written reaction?
Yeah. Which will react? Formic acid or acetic acid? Which will react?
The formic acid.
Why so?
Yeah, Tollens test actually undergoes aldehyde, but not under ketone.
So formic acid is an acid. Where is the aldehyde? But you're right. And how did you know that? Because when you write, draw the structure of formic acid quickly, Ashita. Draw the structure of formic acid. Yeah, if you just see the left side, cover it with the
it is COS.
There's an aldehyde group. So yes, that is why. That's the reason. It has an aldehyde. It's got dual nature, aldehyde and carboxylic acid. So एक को ढको तो दूसरा.
It does have an aldehyde.
Yeah, it has an aldehyde, but you're not sure about that, no? Okay. You get the full 2 marks. Khushi and Amaan has the chance to catch up. Okay, it's a 2-marker question. So if you catch up, then we don't have a winner. We have a tie once again. We'll give a tiebreaker. So I'll give you a question. All right. Like, usually Tollens reagent is, Jones reagent is discarded for lab use. Any one of you can tell me. I give this chance to Khushi and Amaan to, and of course Prisha to answer, just to break the tie. Ashita, if you, of course, you can get the question also. Jones reagent is usually discarded in lab use. Can you tell me the reason why? Any one of you. Jones reagent is actually not used in labs. Yes, Khushi?
Unstable.
Jones
So-
reagent is stable. Yes, Ashita?
Ma'am, Jones reagent is basically CrO3 with conc H2SO4, and as conc H2SO4 is a very strong oxidizing agent, it may cause fire and explosion in the lab, so it's preferred not to use them.
Okay. So Ashita is the clear-cut winner, though she, I mean, that's okay, but the answer was okay, but it's always that chromium compounds are highly toxic. Right? Chromium compounds are very toxic to work with, so actually they are not used. And instead of that, whenever these compounds are taken, Swern oxidation is done. Swern oxidation, SWERN. Anyone, any idea about Swern oxidation? Okay, whatever it is, it contains oxalyl chloride and DMSO, dimethyl sulfoxide. Right? The Jones reagent is being substituted with Swern's reagent. So we have the winner with Ashita with 4 marks. I'll give you that 0.5 marks for stating that sulfuric acid. So congratulations, and you get an Amazon gift voucher. Thank you so much for participating in this show. Thank you so much.